All right, everybody, welcome to the video here for lesson number 9, where we're going to revisit the idea of margin of error and try and figure out how margin of error can be applied to sample means instead of sample proportions. We're essentially talking about the same concept, we're just going to apply it to a different statistic. So because we want to review this, I would like you to pause the video and try the opening exercise. If you need to look back at your notes to lesson 7, which is where this would be, you can do that. All right, so I'm hoping that you paused the video and you actually attempted this on your own. So one of the things, whenever we see the words 95% confidence interval that we're thinking of the confidence interval is equal to the proportion of the sample that we have plus or minus the margin of error. And remember, to calculate margin of error, it's 2 times the standard deviation. Lucky for us, they told us the margin of error, so we didn't have to do that secondary step. So to find the confidence interval, we're going to say it is 0.45 plus or minus 0.03, meaning the confidence interval is going to be 0.42 to 0.48. What the confidence interval tells us is we are 95% confident that the true population proportion is within 42 to 48% voting yes for this politician. Meaning, if we wanted to interpret the results of the candidate winning the election, we can say we are 95% confident the population proportion will not include 50% or more, because 50% is not within our confidence interval. So again, we're 95% sure that the true population proportion is within these two numbers, meaning if 50% is not in our confidence interval, we're not very confident that this politician will win. All right, so let's take a look at number 1. Number 1 in the note says a marine biologist is trying to determine the average length of a clownfish. Explain why the population mean will never be known. So a clownfish, those are like Finding Nemo, right? They are all over the ocean. We're never going to be able to catch them all, right? So you cannot measure every clownfish. It's impossible. So we have to take a sample. So this marine biologist went through and he took a representative, randomly selected sample of clownfish and measured their length. Here are the lengths shown. It says compute the mean and the standard deviation of the sample. The only time I am ever going to ask you to compute the standard deviation is if you're doing it with a sample mean and it's going to be in the calculator using 1-bar stats. So just like I did in lesson 8, we're going to type this data in. So if we take our calculator here, let me grab mine, scroll this over so I can see my data, and we can put our data in. So to put your data in, you're going to go to Stat. You're going to go to Edit. Remember, the trick to clear your list is just hit clear on top of L1 and scroll down and it'll automatically clear. Or you could go through and individually clear the numbers. And then put in your data, 40.2, 53.1, 23.7, etc. Just go slow, make sure that you don't miss a piece of data, make sure you don't type one in wrong. Please try this on your own. You will be expected to do this on a quiz or a test or the Regents exam. This isn't just for funsies where I'm typing stuff in and you're watching me. If you have to pause the video because I'm going too fast on the calculator, that's fine. All right, so now that we have all of our data in, I can hit second quit, The mode button is quit. It's right next to second. We'll hit stat, go to calculate. We'll go to 1-bar stats. Again, make sure your frequency list is blank because we don't have a frequency for this. And hit enter. It's going to tell us the mean. We talked about that in lesson 8, 37.7. So let's put down our sample mean. Our sample mean is 37.7. Our sample standard deviation is called SX. Sample standard deviation is, we'll just round it to nearest tenth, 12.8. If you look on your calculator, it's like the fourth thing down there. The one right below it looks like this. This is the population standard deviation. We really don't ever use that for this class, but it's something that they could ask you for, right? I've never seen it, but it's possible. But it does ask us specifically for the standard deviation of this sample, not of the population of clownfish. All right, so the calculator gives you both. You just have to identify which one you want. So we want sample, which is SX. Okay, so what can the scientists do with this to then try and determine what the true population mean, or the average of all clownfish that exist in the world, the length will be? So the best estimate we have right now is going to be 37.7 because of the theory that we talked about throughout this whole chapter since lesson 2, that the sample, if it's good and representative and randomly selected, will be close to the population values or parameters as well. So we can say the population mean is best estimated at 37.7. Now I want to know how close that really is. What's the margin of error that I can establish to really give me a range of values that the true population mean should fit into? Like, this population mean might not be 37.7. It might be 38. I don't know how wide that range is. So what we have to do is we have to simulate over and over and over again, taking samples of 10 clownfish, measuring them, and figuring out 100 different, or in this case, 200 different samples of clownfish. Notice I'm providing the data here in a histogram instead of a dot plot. It's the same thing. Notice it's giving you the mean and the standard deviation of the distribution, right? This is the statistics of the distribution, and that's what we want to use to create our margin of error and our confidence interval. So again, assuming that we have a 95% confidence level, state the margin of error. So to find the margin of error, we're just going to take 2 and multiply it by 3.78. Right, the standard deviation of the actual sampling distribution, which gives us 7.56. Meaning our sample that we got of 37.7, about 38, is going to be close to or within 7.56 of the true population mean. So if we construct a confidence interval, we're going to construct a confidence interval by taking the mean of the distribution, adding and subtracting the 7.56. Now, if I do that, I'm going to construct a confidence interval that is between 30.44 and 45.56. And what this confidence interval tells us is we are 95% confident the population of clownfish will have an average length between 30.44 and 45.56 millimeters. I think it was millimeters. So we're 95% confident the true population mean will be between those two numbers. Now, if you're that scientist and you're like, hey, That's too big of a range. That interval's too big for me. You have to ask yourself, what could you do to decrease the margin of error? Right? What could I do to make the margin of error smaller, make the standard deviation smaller? So I want you to pause the video for a second and try and answer the last question here on page 36. All right, welcome back. Hopefully you answered this question on your own. Let's see what we wrote here. So if I'm the marine biologist, I want to decrease the margin of error. The only way to decrease the margin of error is to decrease the standard deviation. To decrease the standard deviation, we have to increase, I'm hoping you wrote, the sample size. Give yourself a little pat on the back if you said increase the sample size. That's how we decrease the margin of error. That's how we decrease the standard deviation. Both of those things relate to each other. So by increasing the sample size, not only are we decreasing the margin of error and decreasing the standard deviation, we are also decreasing the spread of the confidence interval. So that confidence interval is going to get from 30.44 to 45, it's going to get closer together, closer to the true population mean. So when we say, what does the 95% confidence interval mean? It's the same as it meant 2 or 3 lessons ago when we did this with proportions. It's if we are in the 95% confidence interval, that means we are 95% confident the population mean is within 2 standard deviations of the sample distribution mean. So just to further explain that, when we construct these 95% confidence intervals, whether it's for means or proportions, we're creating a range of numbers that is going to be, that we're confident the true population parameter lies between. Okay, now we're not 100% confident, we're 95% confident. All right, so here's what I want you to do. I want you to pause the video and try number 4. Okay, welcome back. I'm hoping that you're just checking your work here and you actually listened and paused the video. So to construct a 95% confidence interval, we're going to use the data in the box. We're always using the data in the box. So we're going to say the confidence interval is equal to 75.9 plus or minus 2 standard deviations of 2.65. If we do 75.9 minus 2 times 2.65, make sure I have a decimal in there, we get the lower number of 70.6. And if we do that again, but add it instead of subtracting it, we get 81.2. So there's our confidence interval. To interpret this, we're going to say we are 95% confident the population mean of snapshots, I think you guys just call them snaps, at CCHS is between 70.6 and 81.2. Make sure when you write your confidence interval, you write it from least to greatest. Some people were writing them backwards when we did the proportions the other day. And the last question, could the true population number be 83? The answer is yes, but because 83 is outside the 95% confidence interval, it is an unlikely population mean. right? It's not plausible. It's not something that I would expect to happen. And that's it. That's all I'm going to have you do today. Number 5 is just more of the same. This is a calculator problem, right? This is our calculator problem to do list 1 and figure out the sample stuff. You could go back in the video to see how I did that before, because there's one in the homework like that, right? And you could use the rest of the period if you have any time left to work on the homework assignment here, other homework assignments, or keep working on that Regents review assignment. And I'll see you guys all tomorrow.